Welcome to our lecture online, and here we have one more example of how to do an application type problem for systems of linear equations, because we're going to be dealing with two variables, and here is the problem. The vendor has 74 kilograms of cashews and 83 kilograms of pecans. He places 1 kilogram of cashews and 2 kilograms of pecans in each regular box, and he places 4 kilograms of cashews and 3 kilograms of pecans in each deluxe box. How many of each type of box can he assemble? So what we have here is we have a constraint. Here we're told that we only have, so this is what we call the constraint. That means the maximum number of cashews and the maximum number of pecans are known. Now we have two unknowns. So the two unknowns are the number of regular boxes, and the other known is the number of deluxe boxes. So let x equal the number of regular boxes. And let y equal the number of deluxe boxes. Okay, now we need two equations. So we have cashews and pecans. That will give us the two equations. So cashews will give us one equation and pecans will give us another equation. So how many kilograms of cashews are there in the regular box? 1 kilogram per box, and there's x number of regular boxes. So 1 times x, this will represent the number of cashews in the regular type boxes. And then there's 4 kilograms in each of the deluxe boxes, and there's y deluxe boxes. So 4 times y is all the cashews, the number of kilograms of cashews in the deluxe boxes, and together they must add up to the total number of cashews that you have, which is 74 kilograms. Then for pecans, notice we have 2 kilograms of pecans in each regular box, and there's x regular boxes, so 2 times x. This represents the total number of pecans in the regular boxes, not total number of kilograms of pecans. And then we have 3 kilograms of pecans in the deluxe box, so plus 3 times the number of deluxe boxes. So this represents the total number of kilograms of pecans in the deluxe boxes, and together they need to add up to 83 kilograms of pecans. So there's our two equations. We now want to solve those two equations. Well, let's see here. It looks like we probably can use the method of substitution, because here we can solve this for x. So equation number 1, we can write x is equal to minus 4y plus 74 by moving the 4y to the right side. The second equation still reads 2x plus 3y is equal to 83. And now what we can do is we can take what x is equal to, which is this thing right here, and substitute it into the second equation. So when we do that, we get the following. We get 2 times minus 4y plus 74, so that's 2 times x, and x is equal to this, plus 3 times y is equal to 83. Getting rid of the parentheses, we get minus 8y plus twice 74, that would be 148. That's an 8, there we go. Plus 3y is equal to 83. Now let's move all the y's over to one side, all the numbers to the other side. So minus 8y plus 3y is equal to 83 minus 148. So let's move that over here so we can continue. We have minus 8y plus 3y is equal to 83 minus 148. So let's combine these two. That gives us a minus 5y is equal to, combine those two, that's 48, that's 58, plus 7, that would be 65, so minus 65. Divide both sides by negative 5, and we get y is equal to 13. Now remember that y is the number of deluxe boxes, so that means that our first answer is we have 13 of the deluxe boxes. But now we need to know the number of regular boxes. Well, our equation's right here, x. So we have x is equal to minus 4y plus 74. Now we're going to replace y by 13. So x is equal to minus 4 times 13 plus 74. So we have x is equal to minus, that would be 52 plus 74, or x is equal to 22. So it looks like we can make 22 of the regular size boxes. That would be the other part of the answer, 22. And there are the two answers. When we have this many nuts of each, 74 kilograms of cashews and 83 kilograms of pecans, and we want to divide them as indicated into those two types of boxes, we'll end up with 22 regular boxes and 13 deluxe boxes. And that is how it's done. End of the series.